In this video, we discuss various aspects that have a decisive influence on the quality of AI-based systems. In doing so, we address well-known factors such as bias, functional safety, transparency, interpretability, and explainability. We also cover the less obvious features such as ethical aspects, flexibility, adaptability, evolution, autonomy, and the dangers of unexpected side effects or reward hacking. You may know the ISO IEC 25010 of the ISO IEC 25000 norm family that defines the common quality characteristics of software. But now, the mentioned norm will not contain all the necessary quality characteristics for AI-based systems. Therefore, the ISO IEC 25059 is added to the norm family focusing on AI-driven applications. In this video, I will explain the new quality characteristics in the mentioned new norm, and an additional interpretation of some quality characteristics that are also available in ISO IEC 25010 regarding AI. At the end of the video, I will explain the 7 AI principles of Google as an example of how to compile the most vital aspects into a guideline for your AI-related IT projects. So buckle up and let's dive directly into it. Flexibility and adaptability. We live in an environment that is constantly changing, and AI can also be exposed to a wide variety of environmental influences during its use. For example, an AI for object recognition in road traffic must be able to deal with constantly changing weather conditions or different incidences of light, or speech recognition must be able to process speech despite unpredictable background noise and different word choices by users, different dialects and accents. This is why we want a high-quality AI system to be both flexible and adaptable in terms of its characteristics and the environment it is used in. But it's not just the environment that is constantly changing. Our requirements and the resources available to us are also changing. Most people want AI systems that can easily adapt to changing requirements. The topic of adaptability has played a role in the context of software quality assurance even before AI systems were developed, as ISO IEC 25010 shows. The use of AI means that the quality characteristics of adaptability and flexibility are becoming increasingly important. It is not easy to distinguish between the two terms, flexibility and adaptability. As these quality criteria are closely related, we will explain the difference between the two terms below. While flexibility is about how well a system works in a new environment outside of the originally defined area of application, adaptability is about developers being able to adapt the system to new requirements without much effort. This may be the case if, for example, the available hardware or the behavior of the AI in the operating environment changes. In the following 4 scenarios, you need to pay particular attention to the flexibility and customizability of an AI system. 1. The operating environment is not fully known when the system is developed. 2. The system should also be able to cope with new operating environments. 3. The system should adapt to new situations. 4. The system itself should determine when it should change its behavior. Self-learning systems that continue to learn as they are used are exposed to the 4 scenarios just described, as they must constantly adapt to new challenges and react flexibly to their environment. We expect these self-learning AI-based systems to continue learning during use, and to exhibit all of the above characteristics. The new sub-characteristic functional adaptability is added to the functional suitability quality characteristic in ISO IEC 25059. Autonomy of systems. When we talk about autonomous systems, many people certainly think of autonomous driving. New approaches to autonomous transportation are constantly being presented in the media. Autonomous buses or underground and suburban trains can already be found in various cities. Both researchers and politicians see great potential in driverless transportation. In addition to self-driving buses, trains, and cars, air cabs are a vision that does not appear to be feasible in the too distant future. When we talk about the autonomy of AI systems, we should not only think about autonomous means of transportation for humans. Drones, collaborative production assistants, or household robots can also be autonomous systems. As a society, we hope that the autonomy of these systems will lead to lower costs, faster processing, and more flexible processes. For example, if you look at the self-driving cars that are on the road today, They are not autonomous driving, but semi-automated or occasionally highly automated driving. The vision of the fully self-driving car, which is often referred to as autonomous, is officially classified as fully automated driving. Even if the car takes over driving completely for a certain period, the driver must have a driving license and be able to take over driving in certain situations. Technical hurdles, and socially motivated reasons to the fact that full autonomy is not sought in practice. Fully autonomous systems can entail incalculable risks when used outside a controlled test environment. In the field of autonomous driving, for example, we have heard of tragic accidents with fatalities in the media alongside impressive successes. Systems that use AI components are often described with the adjectives autonomous, smart, and intelligent. Testers need to take a close look here, as not all AI-based systems are autonomous systems in the sense of the definition. Furthermore, our day-to-day project work has shown that AI is often referred to in general terms. With this formulation, it is easy to neglect the fact that complex systems can contain not just one AI component, but several AI components that take on different tasks and are connected to each other. For example, for a self-driving vehicle to perceive and assess its surroundings, information about its immediate environment is collected. Various sensors such as radar and LiDAR sensors for distance measurement or cameras for object recognition are used. Various AI approaches are suitable for processing information from the various sensors and cameras. Thanks to the success of machine learning and deep learning in image processing, they have proven to be very effective approaches for fulfilling the functionalities in an autonomous vehicle. In addition to image processing, they also include decision-making and control functions that are effectively implemented with AI-based components. It is a great challenge to gain an overview of the functionality of a highly automated or autonomous system. It is therefore important that testers are aware of the level of automation of the system under test. This can help determine which features of an autonomous or highly automated system need to be tested. It is also useful to record these in the form of formulated functional requirements. To get started, you can use the following questions to guide you in your day-to-day project work. What level of automation does the system under test have? How long should the system under test be able to operate autonomously? What kind of decisions does the system have to make during this time? What requirements must the system fulfill during this time? How can functionality be validated during the autonomous phase? For which events must the autonomous system hand back control to its human controllers? Evolution. Another quality feature is evolution. We normally associate evolution with the development and change of living beings and societies. If we think of AI as a living being, we can also expect AI to be subject to evolution. We describe the quality characteristic of evolution as the process of adapting an AI-based system to changing circumstances over a long time. When an AI interacts with its environment and adapts to it, it changes its parameters in such a way that it fulfills its function under the changed circumstances. Whether an improvement has taken place is certainly in the eye of the beholder. Just as in the process of biological evolution, not every developmental step is always better, but sometimes just different. In evolution, AI-based systems can only survive in the long term if they can adapt to changing operating environments. Only then will they be successful. This is primarily because the environment in which AI-based systems are used is often in a state of flux. As is generally the case in IT, AI-based systems must therefore also be flexible and adaptable enough to fulfill their purpose despite these changes. Here we distinguish between two ways in which the AI-based system itself can change. The AI-based system learns from its own decisions and interactions with its environment. The AI-based system learns to deal with the changing conditions in the operating environment. Ideally, the system continues to develop in such a way that it improves its effectiveness and efficiency. However, a system can also develop in an undesirable direction. This can cause the AI software to deteriorate or even fail to fulfill its original purpose. Particularly from the perspective of long-term effective quality assurance, the evolving system must therefore be monitored and, if necessary, limited by the operator of the AI. The system must not develop any undesirable characteristics, and the original system requirements and limitations must be maintained. If these requirements and limitations are missing, evolution must be limited in advance, and it must be ensured that, for example, the AI-based system continues to respect all basic human values. The AI-based system can predict part replacement by constantly collecting a car's driving data. To do this, it learns how some of the available attributes, temperature, air pressure, oxygen content, oil pressure, viscosity, age of the oil, age of the individual components, vibrations, etc., relate to the wear and tear of various car parts. The AI-based system evaluates the data and determines that the brakes, for example, need to be replaced. During the workshop visit, the AI-based system then interacts with the workshop technician, who informs the system that the V-belt also needs to be replaced. The AI-based system then adjusts its prediction using all the data collected. This example fits in with the first way in which AI can change through learning. Bias. Another often central quality feature is how the results of an AI-based system deviate from the results that we humans rate as fair. To look at it mathematically, this is not about the accuracy of the results delivered by the AI, or the strength of the deviation in the sense of a variance from the respective desired result, but about the deviation of the mean results from the mean expectations of a fair result, the bias. This describes a systematic offset between the results and expectations. One example that has become known in the press is the AI system that assessed job applications at Amazon. The candidates classified as suitable by the AI were disproportionately male, despite having the same qualifications. This bias was present in the training data. As in the past, male applicants were selected more frequently than female applicants by the HR department. This type of bias is referred to as an inappropriate bias, which you can observe with unintended consequences in many places in the real world. AI-based systems of banks that were responsible for granting loans, AI-based systems that assess job applications, and AI-based systems that were supposed to help in court have failed in practice, favoring or disadvantaging certain groups based on attributes such as gender, ethnicity, sexual orientation, income, or age. A bias can be present in ML systems as well as in expert systems or the experts themselves. Data and humans can be biased because this makes it easier for us humans to make decisions more quickly. At the same time, however, we are also able to critically scrutinize our decisions. When experts reproduce knowledge with the help of expert systems, this bias can be built into the system in the form of rules. In this way, AIs establish decision-making criteria that can no longer be critically scrutinized by human authority when applied. This raises social questions and has also sparked the debate about biased and unfair decisions by AIs. AI-based systems are used to make decisions and predictions. These systems in turn use algorithms that find statistical clusters or patterns in the data. This can lead to various types of bias in the system's output. An algorithmic bias occurs if the learning algorithm is not configured correctly, for example if certain data is weighted more heavily than others. This type of bias can arise, for example, through the settings of the hyperparameters of the learning algorithm. The bias is imprinted here by the training itself, and not by the data. If the learning data is not fully representative, a sample bias occurs. The data space is then not fully represented in the learning data. Imagine the following. You want to use an image classifier to learn images of wolves. Wolves are nocturnal, and your sample data therefore consists mainly of night photos. Wolves that are out and about during the day are not included in the learning algorithm. Here we are talking about a sampling bias. The bias is directly present in the data, for example, due to a subset that is too small and does not provide a representative database for the training. In practice, bias is often the result of poorly selected training data and can be triggered less frequently, but also by an algorithmic bias. Ethics. In the context of AI, ethics is a topic that we like to discuss frequently. Unfortunately, AI sometimes comes off badly in such discussions, and we think of Skynet from the Hollywood film Terminator. However, things look very different when viewed in the light of day. AI-based systems have a hugely positive effect on our lives. But now that these systems are being used more and more, there are also concerns about whether they are being developed and used ethically. This is not the only reason why we consider ethics to be a very important issue and even a success factor for AI projects. In the definition, the term system refers to a collection or network of principles in the philosophical, not the technical sense. What society considers to be ethically correct and what we would not ethically accept changes over time. Not only we as individuals but also the society in which we live continues to develop. What we thought was ethically okay 100 years ago would no longer be ethically acceptable today. Nowadays, if there is a feeling that basic ethical principles are being violated, this can lead to a shitstorm on social media. All project participants want to avoid such a shitstorm if it is related to our company's product, campaign, or service. Society is constantly changing in terms of its ethical attitudes. It is therefore important to consider in AI projects that the data used may have been collected at times or in regions where different ethical standards apply. It is also interesting to note that historical data often contains an ethical majority opinion. However, for a long time there was not a sufficient majority for a broad social discussion that would have led to an ethical rethink and ultimately to a change in the law. Ethical principles also differ greatly from region to region. For example, data protection plays a different role in Europe than in America or even in authoritarian states. We cannot imagine scoring systems in Europe that are already in use. Side effects and reward hacking. After training an AI, you often do not always observe the desired behavior of this AI. In this section, we explain why AIs also like to cheat by taking every requirement literally and always getting the maximum out of it, no matter what the cost. And in the end, you can't even blame the AI because the AI simply didn't know any better. Every AI has a goal during execution, usually represented as a target in the form of a mathematical function that it tries to minimize, deviation between the AI's prediction and the actual value, or maximize, as is the case with reinforcement learning. This function is called the reward function, or fit function. The drive of every AI is to behave in such a way that the result of this mathematical function achieves the best possible value. It is therefore clear that when the AI-based system attempts to achieve its objectives, side effects as well as reward hacking or unexpected behavior can occur or even have harmful effects on people or the environment. Side effects. Negative side effects can occur during the development of AI. In most cases, this is because the corresponding targets have been defined in an ill-considered manner, and the completion of specific tasks is focused on the immediate area, but other aspects in the potentially very large environment are disregarded. As a result, the AI does not consider certain environmental variables in its behavior, the change of which could be harmful. In the following, we consider an autonomous vehicle as an AI-based system. The objective is for the car to reach its destination as fuel efficiently and safely as possible. The side effect is clear. The car drives very slowly. This would certainly annoy potential passengers. The AI has stuck to maximizing the target function. In our projects, we also observe positive side effects. However, it is usually difficult to recognize them as such. In the example above, targets could be defined as reduced tire wear. As a side effect, the AI drives without abrupt braking or high acceleration, and the occupants are much less likely to feel uncomfortable while driving. Such side effects are usually caused by some kind of causality that the observer of the system simply could not recognize. It is irrelevant whether the causal relationships are present in the data or not. Ultimately, they are not visible in the data because they are well hidden, because they were removed during the pre-processing of the data, unknown knows, or because they were not recorded at all, unknown unknowns. Reward hacking. Some learning methods for AI impose few or no additional restrictions other than a target. The AI should achieve precisely this one goal. How it achieves this goal is not considered here. We speak of reward hacking when an AI-based system achieves a specific goal through a particularly clever or simple solution. In doing so, the AI twists the mind of the designer's intention. This person had an idea in mind of how the AI might achieve its goal. However, AI then takes a completely different path. For example, an AI-based system could teach itself to play an arcade computer game. The goal is to achieve the highest score. The AI then simply writes a made-up high score with its name into the database. Transparency, interpretability, and explainability. Decisions that until recently were only made by humans are now increasingly being made by AI-based systems. These decisions often have far-reaching consequences for the individual or society. AI-based systems grant loans, make diagnoses in hospitals, and recognize people in autonomous driving, to name just a few examples. AI-based systems are generally used in areas where users need to trust these systems. But how can we all trust an AI if we don't know how an AI makes decisions and what influences its decisions? AI systems are now so good that users are sometimes not even aware that they are not interacting with a human, but with an AI. At the same time, AI methods have become so complex that it is impossible even for data scientists to fully understand the systems. We call a system where we have no insight into internal processes a black box. To still be able to trust these systems, the quality characteristics of transparency, interpretability, and explainability are of particular importance. These quality features are not just about systems that physically interact with the environment, such as an autonomous car. Transparency, interpretability, and explainability are also of central importance when it comes to privacy in the handling of personal data or potentially life-changing predictions and decisions. How much you need to know about the processes in an AI depends on the risk associated with AI. For example, an AI in the medical field has significantly higher requirements than an AI that places personalized advertising. The new sub-characteristic user controllability of the interaction capability quality characteristics is solely available in the ISO IEC 25059 norm, transparency. We talk about transparency when it comes to how easily the algorithm and the training data used to create the model can be determined. Information about the learning algorithm, the origin and preparation of the training data, the frameworks used, and the deployment can also contribute to greater transparency. With appropriate transparency, it is possible to assess the quality of the training data or gain confidence because a renowned framework was used for training. Even if this information is accessible, most people do not understand how artificial intelligence makes decisions. Transparency alone is often not enough to understand which factors influence an AI's decisions and how. In addition to transparency, the two characteristics of interpretability and explainability are also important in this context. Interpretability. In the following, we look at interpretability. We speak of fully interpretable AI approaches when a stakeholder or user without AI knowledge understands how the AI system works, and how the behavior of the AI is achieved. Rule-based systems are, by definition, fully interpretable if the rules can be viewed. Research is now providing ever better AI models that can solve even very complex tasks with a high degree of accuracy. However, the higher the accuracy of the AI model, the lower the interpretability. Choosing a less complex approach is one way of increasing the interpretability and therefore also the trustworthiness of an AI. However, this often means accepting reduced accuracy. If AI approaches are so complex that they cannot be interpreted, it may be necessary to refrain from using these approaches. This is why we also speak of an interpretability-accuracy trade-off. As the complexity of an AI system increases, it becomes less and less interpretable. Most developers and users believe that in 5 to 10 years' time, complex models from the field of neural networks will be the most important type of model in the field of AI. Interpretability will then no longer be sufficient to understand how an AI system has arrived at a certain result. Explainability. Now we come to the concept of explainability. Explainability indicates the ease with which users can understand how an AI-based system arrives at a certain result. To make it accessible how an AI-based system has made a decision, tools are usually required. This has given rise to an entire field of research that we call explainable AI or XAI. This has set itself the goal of processing AI decision-making processes in such a way that they are not only understandable for experts. In this way, the experts want to enable a deep understanding of the factors that influence the decisions of an AI and increase the acceptance of AI systems. Explainability is particularly important for AI-based systems that make decisions with far-reaching consequences, such as medical diagnoses or the categorization of job applications. There are various approaches and tools for explaining the factors that influence an AI's decision. As already explained, a decision tree is a rule-based approach that is fully interpretable and explainable if each decision within the tree is clearly defined and comprehensible. However, some decision trees become very large or use input values multiple times, which can greatly reduce their explainability. The naive Bayes classifier, for example, can be interpreted and explained as a probability-based model. The calculations and assumptions on which the model is based can be analyzed and understood directly. If a more complex non-rule or probability-based model had been chosen, the interpretability would have decreased. More complex AI technologies, such as deep neural networks, often require additional tools and techniques to explain and interpret their decision-making processes. The transparency of a model depends not only on its complexity and structure, but also on the quality of the documentation and the accessibility of the technical details. Rule-based and probability-based models are generally more transparent because their decision processes and criteria are clearly articulated and understandable. The new subcharacteristic transparency of the interaction capability in ISO IEC 25059 deals with these ideas. Functional safety. We all expect every product that we use within our sphere of influence to be safe. Among the various safety aspects, functional safety plays a special role. It should ensure that no damage is caused to people, property, or the environment during the operation of a product. However, when particularly complex systems such as AI-based systems are used, it is practically no longer possible to describe all scenarios of use with requirements and safeguard them through tests. AI-based systems are often used in sensitive areas such as medicine, manufacturing, defense, security, or transport. There, they interact with people and the environment and make decisions whose functional safety must be ensured by the manufacturers. It is therefore important that testers are aware of the characteristics of AI-based systems that make it difficult to ensure functional safety, such as complexity. Processes in AI-based systems are often no longer understandable or directly accessible to humans. This represents a black box, non-determinism. This describes the inability to predict the behavior of an AI-based system because too many factors influence the behavior of the AI-based system. Probabilistic character. If a system does not always behave in the same way, but a certain behavior occurs with a certain probability, then we speak of a probabilistic character of the system so that the behavior cannot be predicted with certainty. In contrast to non-determinism, however, it is possible to make a statement about the frequency of the behavior for many repetitions of the same situation. Self-learning systems. If AI-based systems continue to develop themselves, they adapt their behavior over time. This means that the proof of functional safety can no longer be transferred to the modified system. Tests are then no longer valid as the underlying software has changed in the meantime. New tests must then be designed and carried out for the modified software. Now, safety is a very important quality characteristic of the ISO IEC C 25010 and ISO IEC 25059 norms. So, there are a lot of things to keep into account when we are developing AI-driven applications. For instance, Google has compiled in 7 principles to guide every of its AI projects. 1. AI should serve social good. Every AI initiative must consider a wide spectrum of social and economic impacts. Projects will move forward only when Google determines that the expected benefits significantly outweigh potential risks and drawbacks. 2. AI must avoid unfair bias. Google is committed to minimizing unjust outcomes, especially those affecting individuals based on sensitive attributes such as race, ethnicity, gender, nationality, income, sexual orientation, ability, or political and religious beliefs. 3. AI must prioritize safety. Robust safety and security measures will be integrated into AI development and testing to prevent unintended consequences that could cause harm. 4. AI must be accountable. Google will design AI systems to ensure they offer meaningful opportunities for feedback, explanations, and avenues for appeal, promoting accountability to users. 5. AI must respect privacy. Privacy-centric design will be a core principle. This includes providing clear notice and consent, implementing strong privacy safeguards, and ensuring transparency and user control over data usage. 6. AI must uphold scientific integrity. Google will maintain high standards of scientific rigor, collaborating with diverse stakeholders and utilizing multidisciplinary approaches. Additionally, the company will responsibly share AI knowledge through publications, educational resources, and best practices to empower broader AI innovation. 7. AI must be used responsibly. Recognizing the dual-use nature of many technologies, Google will strive to restrict applications that could lead to harmful or abusive outcomes. So that's it for today. A lot of stuff, I suggest. If you have any questions, please comment, and we will answer them soon. Please like and share this if the information is helpful. Subscribe to our channel to keep you informed about the latest QA news. Happy testing!